Hello and welcome. Today, I'd like to share a little bit about the things I've been working on with computer science, and I think primarily that would be my website. But as I got it set up and staged to show off, I realized that I'd been using a deprecated package for a while that, oops, now I gotta remake my website. So, okay, what we're gonna do today is kind of go through the process of abstraction and how sort of I incorporate a continuous dynamic within a discrete existence. So basically, first off, we have to get to the point. Why did I fail math so often? Well, what even is a number? When you think about it, there's not even a real zero. So I got my little drawing pad here. I'm gonna show it. So what is a number? Well, we got 1. Okay, and then when we get to 2, we haven't actually gotten anything new because when you think about it, between 0 and 1, you kind of have like the first half, and you have the second half. And it's, so like within those two, you kind of, you're already there. You don't need to go to 2. Well, and without 2, you can't really go any higher than 1, so 1's pretty much the biggest number, and when you're talking about big numbers, well, that's infinity, and you can't even get to infinity. So we have from 0 to infinity, and then when you divide infinity by infinity, well, I mean, you get back to 1. So obviously infinity can be broken up into groups of 1. That's not how mathematical operators work, but who cares? No one really likes math anyway. But when we get into sine and cosine, I think that we'll see that there are 2 dynamics that exist, and that is the idea that there is the linear and the circular. And now I'm going to show, if we look at the base of systems, you have, say, 2 to the 0, 2 to the 1, and 2 to the 2, 2 to the 3. We'll just do a quick hexadecimal thing because each of these is a bit slot. It can either be 0 or 1. And with 0 or 1, well, that means obviously we have 2 positions each slot can be in, which means at any given point in time, every one of them has a 50-50 shot of being in their spot. And this is going to get into kind of how I structured my dice roller on my website, because I didn't do anything like that cryptographically enhances it. Rather, I took the determinant information that there is a seed based in the time, and then created a distributive function to apply that, knowing that that application would be dependent on the hardware processing the calculations, which, even though a computer can do it incredibly fast, there are always so many factors on the outside that it would result in one cause of the numbers leading in an anomaly state, whereas the rest of the numbers would kind of remain consistent. And so from those 4 options, let's say if it's a 4-sided dice, then you can get an even distribution of them. Oh, we're working in hexadecimal, sorry, that's what we were supposed to be doing. So anyway, with 4 bits, you actually have 16 different states that can exist. But if you have 16 different states, well, hey, why don't we just do a 16 to the 0? And now you have your 0 through F of hex. And that's the foundation of, like, switching into different counting systems. If you can break a number down into a system where, say, properties are different, you can fundamentally change the point at which the information is interpreted. And that allows you to move at a rate outside of the bounds of the initial problem. So, I mean, I think my mind kind of gets a little abstract and it's hard to keep it focused to explain this. But within these sort of bits here and this 16-state system, we can then form systems of, with these 256, and some people think to themselves, well, hey, 256, that doesn't make it much faster if you're losing information within those states. And that's where relative measurements start to affect the way in which an outcome can be derived from an initial problem set. And in that, you can define state transitions rather than computations. And those state transitions can procedurally sort of like bypass a computer's need to put something in a queue because, oh, we're not doing anything big here. We just got to swap out this small state for this other small state. Now, I have a lot of problems with computers, mostly with like touching them or using them at any point in time. But the thing that I feel I bring to all my work is that I have a means of approaching problems that is outside the norm, and because I'm able to bounce off the wrong ideas, I can wind up near the correct ideas faster than I think normal like processing would typically allow someone to do. And that's not to say like I am not smarter than anyone. I got a little bottle of gloop that I got, I think I gotta put it up on the side, but the idea is, how does an electron move at the speed of light while simultaneously spinning in place and at the same time oscillating relative to a center point? And so when you consider that, there is, say, 1 light year. I'll just draw a little diagram for you. And then around that light year, you got the electron, and it's bumping at its frequency. Because, I mean, if we just electromagnetic, consider just normal light. The sun's shooting its rays at us, and we naturally see an impact from the effect of these, like, energies, but we don't sort of isolate the point at which that energy is translated to life in a way. But that's because what if, as the sun is hitting the Earth and the magnetic field of the Earth is impacting the rays of the sun and all these different factors are playing into a certain degree of like passing off, this circular form were no longer circular, but it became bent in a way where it were then traveling parallel, not the entire way, but at certain points within that element. Because let's say it were an oval, the oval at the point of the middle where it's at its highest would be around its highest for a longer duration than the point if it were a more like narrow frequency band. And so overall, while the energy isn't fundamentally changed between the two states, both states are occurring independent of one another because there is the one that is and the one that isn't, but they have to be together. So what if we did a base 1 system? That'd be kind of cool, right? Well, what's 1 to the 0? We get 1, and then 1 to the 1. We get, wait a second, that's not the same as those other number systems. What if we do 1 to the 2? Oh, gee whiz. Holy cannoli. Every time we put 1 into a base 1 system, well, any number to the power. This 1 in the exponents isn't working like the normal numbers, but at the same time, in this series of 3 numbers that we identified at the beginning of what numbers are, 0 times any number turns it into 0, and infinity times any number turns it into infinity. 1 times any number has no impact, so 1 must not exist, right? That's the only reasonable conclusion that we can draw. So we have 0, the absence of things, obviously does not exist. Infinity, the presence of so many things that they are innumerable, because as soon as they are defined, they then are the antithesis of that word which defines it, which is to say infinite, without finitude, I don't know. I hope some of this is kind of like making sense, because we're going to look at some charts later, and well, fuck, we kind of just blew all our goddamn time. Okay, now, I'm going to assume you know what numbers are. Congratulations, they don't exist. Not until you define a set of things does that set exist, because it's when the set is defined that the bounds upon which, like, separating that set from things not of that set are created. And those bounds exist, but the actual set is the conceptualization of the set, not the set itself. So, if a robot can emulate your work so closely that they're able to replace you, were you ever really living? I think that we're just gonna have to do food for thought. Also, okay, this is actually something. Have you noticed vibe coding? At what point did, like, not knowing what you're doing become, like, the cool thing to do? Because, like, I don't know. I sit and don't know what I'm doing all the time, and I never say, oh yeah, I'm just vibing. Well, actually, hold on. I do say that. Never mind. Okay, we're gonna get into design theory. So basically, I put it in big letters. We're not having hamburger buttons. That's the one thing about the website. And you can see my website now. It's at stickybasket.org, but I want you to know that's just a work in progress, because the actual website is coming soon. And no, this isn't like Dark Souls where it's gonna get delayed and delayed. It's just, okay, so I have this set of projects that I'm working on, and each one of them requires a various, like, layer of programming. And so trying to bring these languages into one spot and translate them to JavaScript has been a challenge, but on top of that, as I run up against the limits of what JavaScript can do, Python has been helping me sort of incorporate things like mathematical plotting, because at some point I would like to get involved in data compression techniques, and with, like, the gloop and the whole idea that an object can represent more than that which it looks like, or that which is of the visible form. The idea is, how do we quantize data, encode it, and then encapsulate it in a way that we can deliver to others so that they can decapsulate it, decode it, and interpret the raw, like, base set with the most fidelity. So the idea is the capacity to create information easily transmissible, and the easiest way to sort of make something out of a mold is to have a mold, you know? So I'm trying to build the mold for something that I don't know if it exists, and a couple of weeks ago it meant I made a prime number counter that does what, you know, every prime number counter does, and at the same time, not much better than prime number counters normally do. Okay, can I get my mouse? Okay, we're touchpadding it. So in here, I have some functions. RNG Supreme is kind of that one I was talking about, where if you toss it 4,096 times, one of them is guaranteed to be the anomaly case, and that anomaly case is distributed randomly each time. Now again, do I think that that's true? Yes. Is that actually true? Don't Google it. Just nobody ask. I've also gotten, in my cryptography class, we did something called Euclidean something. This is a way to calculate within a set what number would be the inverse of that number, the inverse being defined as the number that makes it become 1. Now, this is interesting because within the realm of things like resistors in series and parallel, the reciprocal of the resistance is what creates the total resistance across parallels, in that it's the reciprocal of the sum of reciprocals of the resistors, which in turn means there are additive properties taking place under division, which are making things between sort of like the outside set and the inside set. If the outside set is 1 and the inside set is 0, well, now we have every number that ever could exist. And I mean, if you can get to infinity before you even get to 1, I don't even know if you can get to 1. So when people say, oh, I don't know what people only have 1 of. I don't really pay attention. Most people believe that they have like the afterlife, and then they got the life before this, and I mean, I am sure that to some extent the energy that inhabits our physical or corporeal form is like permanent to the universe, but that's just like because the laws of physics and thermodynamics state that the energy isn't created or destroyed, and it's like not when it is or isn't, it's the dance between the two of the light switch in the middle where the infinite possibilities arise. Anyway, sorry, I'm back into rambling, and now I don't even know if this camera's filming anymore because I don't have my clock because I'm filming the gloop for y'all, and oh my, did I just, damn it, I closed my code for the JavaScript, but we'll go to the graphs. The logarithm, sorry. This is one that I really like because it's logarithms, and logarithms are basically, if you got a number and you're taking like log base 10 of 10 is going to be 1 because 10 to the power of 1 equals 10. So your exponent is found through the logarithm of the base of the element you're like making inquiry of, because all you're basically asking is, hey, if I got this number and you got that number, what number do I put in the exponent to just kind of like take, I don't want to do any of that multiplication or that division or the stupid stuff. Let me just exponentiate this baby all the way back up to the truth, you know? And, okay, sorry. I wanted to show you my graphs. Oh, that's OBS. Okay, so the website, not great. Here's the, okay, data visualizer. So sine and cosine are interesting functions because in sine and cosine, hopefully you can see, but there are in the dark green and the hot pink lines, these alterations that take place, and those are naturally sort of like just the shape of that object, and it happens to operate in like a 2 pi cycle period, and there are kind of like all these different irrational numbers surrounding the layer of a circle. But I have been typing numbers into the computer and making my computer do a bunch of things that I don't want to do. And now I got all this big mess on my computer of like lines and stuff. But what I started to consider is, what if there's a way of measuring the state of each line relative to one another, and then instead of transmitting base data, transmitting the changes in state and the interval of time through which they occur on a given sine period. Now, this is not new. This has been theorized in several papers. I'm not gonna go too far into it. Hopefully someday I'll get to do more work with that. But the idea is, how do you get these to show up in a meaningful way that then can be used to transmit more than just lines on a graph? And so that was the data visualizer, which, that wasn't even the one I wanted to show you. I wanted to show you the basic waves, because that's where the, alrighty, fucking up the order of this stuff. Hopefully oh god, and that's not even, oh shit. We're gonna go to the extreme numbers, because that's, surely that's cool, right? That was, one of these numbers is supposed to be tetrations, and a tetration at 0 only reaches a point that so a tetration approaches towards 0, but as it approaches 0 on the x-axis, it's approaching 1 on the y-axis, and a tetration is essentially a number to its own power. So within a number 25, for example, 5, nope, that's not true. 5 squared is 25. 5 tetrated is a big number. 3 tetrated would be 27. Or 27 tetrated would be 3. I don't know which way it goes. I didn't pay attention in math. Sorry. I was showing... I hope that Gloop did something interesting on the camera, because I don't really know if any of this stuff is, like, doing stuff, but the idea that I have right now is that if I can incorporate light into the ion and polar sort of salt and sugar, the combination hopefully will take the two, and since that's seeded with, like, magnetism and amber and, like, all this stuff, it should be doing something that is, like, not normal for a bottle of fermented sugar, which I guess inherently isn't normal. It's all good. It's all good, because we're a work in progress. That's what DevLogs is all about. We're not at the finish line. We're hardly even at the starting line yet. Holy cannoli. But thank you for joining me. I'm looking forward to season 2, because holy shit, it's almost the end of Hot Girl Summer, and we didn't even do the Cat Girl Beach episode. So we got plenty of things coming up. I don't know. I'm gonna be honest. I just at one point these calculations and these numbers started adding to make symmetrical lines, and it started to make me think, what if you could calculate a circle without ever needing pi? Wouldn't you have just simply redefined pi, which fundamentally shifts the basis of calculating relative to, like, the 0 and... Oh, wait, no, that was supposed to... Between the 0 and what... Oh, fuck, I forgot where pi and the irrational numbers go. Oh, they go kind of everywhere. Well, it depends how far you follow them. But, like, they go, like, as long as you're looking, you know, they become more and more precise. They're not quite to the answer yet, but they'll get there eventually. Kind of like us sometimes. Anyway, I look forward to seeing you in the next one. And hopefully I will have a normal fucking website and be able to teach you some of the more nuanced code things. I'm sorry, I started waving too soon. Love you, bye!